Thank you. Right, I'll just say so. Welcome everyone to our weekly call. I hope you all enjoyed the weekend and are now relaxed and raring to go. Particularly those of you in the US who maybe some of you had the week off last week, or at least a few days off for Independence Day, etc. Okay, let me just share my screen just for a brief moment. Right. So, just as a reminder, in terms of our agenda today, in a second I'll hand over to Andrey. So, as you're hopefully all aware, Andrey Meshkov is joining us. Andrey is the CTO from AdGuard, and he'll be talking about experimental support for Encrypted Client Hello within the various, or at least I assume various, he'll no doubt clarify which of the relevant AdGuard products. And then, as always, we talk about some recent developments, forthcoming events, future call topics, etc. And time permitting, we'll pick up on anything else that anyone wants to raise on the call. So without further ado, let me just stop sharing my screen. Welcome, Andrey. Thanks for coming on. I think AdGuard, one of the very first companies to announce experimental support for ECH. So it'd be really interesting to hear some of your experiences and anything you want to share along the way. So over to you. Look forward to the update.
Hi, everyone. Do you see my screen?
Yep, it's working really clearly. Same with the sound.
Okay, great. Thank you, Andrew, for the introduction. So my name is Andrey, and I'm a CTO at AdGuard. And this time, I would like to tell you a little bit about our experience with Encrypted Client Hello. So this is a new technology that is supposed to fix the issue with the last bit of important unencrypted information in the internet traffic. But before that, before talking about Encrypted Client Hello specifically, let's take a quick look at the history of the question. This might help us understand better the need for it and how the adoption will progress with time. Well, logically, the first thing I would like to take a look at is HTTPS adoption. So here's a slide with a simple timeline of how it was being developed. Basically, we can split the HTTPS adoption process into three big stages. The first stage is from 1994 to approximately 2007, and during these 13 years, many of these standards related to HTTPS are published, are developed and then published, and then certificate authorities come into being, and the CA browser forum is created. By the end of that period, a few websites generally related to banking or e-commerce, they start using HTTPS. Then starting from 2008 to 2012, approximately again, the move to HTTPS begins, with Google taking the lead and Twitter and Facebook following. And so it starts with Gmail, then search for logged in users, then and then search for anonymous users, and so on and so on. And once Google mostly moved to HTTPS, it starts pushing the whole web to go there. And Google begins aggressively pushing for that first by stating that HTTPS will be a search ranking signal, then by declaring that Chrome will eventually mark plain HTTP websites as not secure. And well, the move to HTTPS intensifies and finally reaches the final stage at about in about 2019 or something like that. And as you can see on the slide, from 2019 onwards, the share of pages loaded over HTTPS stabilizes at about 90 to 95%. And well, now well, not half, most of the internet traffic is encrypted, but there's a lot of metadata that is still unencrypted and still, well, your ISP or any other sort of third party can observe and will use. And the other important bit of metadata that needs to be encrypted is, well, naturally DNS traffic. That's why there's a big push to encrypt DNS, and we're all a part of it. And I can say that it probably started in about 2014. Maybe a little bit earlier than that, when DNSCrypt was developed. I didn't mention it on this slide, but still DNSCrypt is also, well, an important step, an important milestone. From that time to about 2018, there's a lot of work on protocols standardization. DOT becomes a standard. Then in 2016, DOE becomes a standard. Probably not 18 in 2018. And after that, from 2018 to 2022, we observe gradual adoption of these new standards. Apple, Google with Android and Chrome, Microsoft with Windows, Mozilla, they all provide options to use either DNS over TLS or DOE. At the same time, the work on related standards continue, and it's important to mention a couple of them. DNS over QUIC becomes a standard, and there's the work on DDR, discovery of designated resolvers, is underway. But it's already getting adopted by Microsoft and Mozilla and others. And now we are in 2023, and the actual usage of encrypted DNS remains minuscule. But let's take a look at how it's progressed with HTTPS. It took us 13 years to finish with the standardization and to start supporting HTTPS in every browser and operating system. And only after that, the push to HTTPS actually began. And with DNS, we're a little bit faster than that, but probably we can assume that it will also take lots of years to fully adopt encrypted DNS. So, well, once we're finished with DNS, we're coming to the last important unencrypted bit. And this bit of metadata that is still transferred in plain text is server name indication. What's that? Every time the client tries to establish an encrypted connection, a TLS encrypted connection, it sends the first message that is called client hello, and this message contains the name of the server in plain text. Why is that required? This is quite important because this allows hosting several different certificates on the same IP address and port number. Well, that's important to be able to do that, because the prices of IP addresses skyrocket high, and there are not many IP addresses left. But why is it a problem? There are two big issues with plain server name indication. The first issue is tracking. And just to give you a few examples of that, major ISPs are known to use all the metadata that they can observe for targeted ads, basically for building their customers' profiles and then using it for targeting ads in this or that way, or maybe selling to third parties. AT&T had a program like that known as Internet Preferences, which was allegedly closed, but well, I doubt they stopped collecting this information. Comcast has been reported to use its data to create targeted advertising, so that's a problem. The second issue is censorship. And SNI kind of relying on SNI for blocking is employed by every major government censor in the world. So China does that, Russia does that, Iran does that. They all rely on SNI to block forbidden domains. Although I am pretty skeptical about ECH solving the issue on a large scale. I doubt it won't magically render great firewalls useless. But nevertheless, it is a very good tech that can be used to circumvent censorship in some particular cases. Before talking about ECH, it's important to discuss its predecessor called Encrypted SNI, ESNI. And as its name implies, the goal of ESNI was to provide encryption just of the server name. To do so, the client would encrypt the SNI extension using the server's public key and send this encrypted SNI to the server. The server will then attempt to decrypt the cipher, the encrypted SNI, using the secret key corresponding to its public key. If decryption were to succeed, then the server would proceed with the connection using the decrypted SNI. So, well, what's important here for the DNS community? For key distribution, ESNI relied on DNS. In order to use ESNI to connect to a website, the client would need to send a request for a TXT record, which contains the ESNI public key. And you can see it on the slide. Step 1 shows how it looked like. But there were some issues with ESNI in general. The first issue is that ESNI server was supposed to abort the connection if the decryption fails. And this case could very well happen. The thing is that keys are rotated. For instance, Cloudflare in their implementation rotated ESNI keys every hour. But due to how DNS caching work, the client might very well get a obsolete key that cannot be used anymore. And then due to that, the server won't be able to decrypt the ESNI, and the connection will simply fail, and it's unclear what to do next. The second issue with ESNI is that a single ESNI TXT record cannot handle a case with several endpoints with different capabilities. For example, let's take one domain, like, I don't know, example.com. It might have two different IP addresses, each of them operated by a different CDN. But there's only one ESNI record for both of them, and it cannot contain both CDN's public keys at the same time. So, well, there's just no way to solve this case. Despite all these shortcomings, ESNI was an important step forward, and it led us to Encrypted Client Hello. Encrypted Client Hello is a development of the same standards. If you take a look at how the draft, the RFC draft called, it has ESNI in the URL, in the name, but it solves all the shortcomings of ESNI. First of all, it does not rely on TXT records anymore. Now it relies on a new HTTPS resource record for the keys distribution. Second, it doesn't encrypt just the ESNI. There's a lot more data in the client hello that you might want to hide from the observer. So it encrypts the entire client hello. And finally, and probably most importantly, it can retry the connection if the ECH server fails to decrypt client hello. Let me explain each of these points. So the first one is about keys distribution. First of all, the client needs to discover the public key that will be used to encrypt the client hello. In order to do that, it sends a DNS query with a new type called HTTPS. And this is a new resource record type, which is intended to allow multiple HTTPS endpoints to advertise different capabilities of for TLS. As you can see on the slide, this Cloudflare domain, it has just one HTTPS record, and this record contains lots of information. ALPN, what version of HTTP protocol to use, IP addresses, and finally, ECH configuration. So ECH configuration, it contains the public key, the cipher suite to use to encrypt client hello, and a bit more metadata. Now, once we receive the public key, we can get to the next step, which is the handshake. And the client that uses encrypted hello, it basically constructs two client hello messages. The outer one, that looks like an encrypted one, and the encrypted one that is transferred in a TLS extension. The encrypted one should also be called the inner one. If a server doesn't support ECH, it response is based on the outer client hello, and it allows for a normal partially unencrypted connection. If it does support ECH, it decrypts the inner hello and proceeds with the fully encrypted connection. The server completes the handshake with just one of them. If the decryption succeeds with the inner one, if it doesn't, without one. Now, the interesting stuff begins when the server fails to decrypt the inner client hello. In this case, it won't just like close connection like we saw with ESNI. Instead of that, it will handshake with the outer client hello, but then through this already encrypted connection, it can signal to the client that its intended destination couldn't be reached due to decryption failure. And it will also send along the correct ECH public key with which the client can retry the handshake. Basically, what it means is that ECH could work without DNS, actually. So DNS is not like strictly required for that. It just it just allows us to have a single attempt at handshake instead of 2 attempts. But generally, well, I think you could implement a solution that works without DNS infrastructure at all. So this new algorithm, it solves the second ESNI issue, making ECH much more reliable. Finally, to our experience. So AdGuard develops several products, and for my today's talk, the important ones are AdGuard Ad Blocker, which is a network level content blocker that filters HTTPS, DNS, etc., and blocks ads and tracking system wide. So the important point here is that AdGuard filters all the devices' network traffic. And the second product that is important here is our public DNS resolver. And using its data, we can estimate the adoption of ECH at the moment and how it progresses. So what we did is in AdGuard Ad Blocker is we added a new feature that to our Windows and macOS apps. This is an experimental feature which is disabled by default, but available under advanced settings. And here's what it does. AdGuard apps filter most of the network connections. So when this feature is enabled, AdGuard attempts to establish an ECH-enabled connection on behalf of the app that actually tries to connect. Therefore, AdGuard adds ECH support, regardless of whether the browser or the app that tries to create the connection supports it or not. Well, that's kind of it. Since it's experimental, we have some feedback from different users that tried to use it, but now we run into a different problem. There are not too many ECH-enabled servers out there. And let me show you what I mean. First of all, some screenshots from our AdGuard DNS resolver statistics. So here's what I observed. First of all, about HTTPS resource records. This is a new one, and there are not too many client software that actually tries to resolve it. More precisely, as far as I know, at the moment, only Apple devices request HTTPS resource records. But they don't use it for ECH, just for discovering TLS capabilities. And on this slide, you can see that the share of HTTPS queries is really, really small compared to everything else. On the other hand, the data is a little bit skewed because we cannot, we have lots of Android devices using AdGuard DNS, and well, at some point when Google decides to implement HTTPS support, we will see huge growth. But at the moment, there are none. And finally, the number of clients that actually try to request HTTPS to discover whether the server supports ECH or not is close to 0. And how many ECH-enabled servers are out there? And we also did a quick check using AdGuard DNS, and here's what we saw. There are several proof of concept domains that always return ECH configuration, regardless of where the DNS query was sent from. And besides of that, Cloudflare tests ECH support in some different locations, but mostly, if not only, in the US and Canada. Most of the DNS responses with ECS config we saw on our American servers. And on this slide, you can see an example that on these servers, responses with ECH config are about 0.25% of all responses to HTTPS queries. So basically, the number of domains that support ECH is not too high, and you can only encounter them if you live in the US or Canada. But that's at the moment. Cloudflare intends to roll out ECH in the future, and the situation may drastically change if Cloudflare pushes a button. Because, well, they have all the necessary they have everything implemented. They could do it like in no time. Also, the RFC is also developed by a Fastly representative. So I suppose that once it's finished, there's a big chance that other major CDNs will also adopt ECH, and we will see huge growth rather quickly. And some related links in the end, if you want to learn more about ECH and related stuff. As you can see, ECH RFC is still draft, HTTPS and SVCB RFC is also still draft, but they are adopted by lots of software, including browsers and AdGuard. That's it. Thank you so much. Ready to answer your questions.
Thanks, Andrey. That was very interesting, as always. So appreciate running through that. As you said, just a couple of comments, then I open up for any questions people have. The standard isn't ratified yet. I think the emphasis is still on interop testing. So the sort of volume of traffic is not surprising given where the standard is. But yeah, clearly that could change. A few other quick comments. You mentioned about sort of use of sort of DNS information for targeted ads by ISPs. As I can't see anyone on the call from Comcast, I can say that their policy is really clear that they definitely don't use the DNS data for any sort of monetized activity. They've got a very clearly worded in plain English policy on that, commendably clear in my view. I suspect that's probably also true of AT&T. It's definitely true, I think, of most of the European ISPs because of GDPR. Clearly, other parts of the world that may be different.
But I was not talking about DNS. I was talking about SNI. But you're right. I rely on the information reported by all kinds of journalists, and you know the quality of journalism these days is not
yeah,
so high.
Yeah, absolutely. A couple other quick thoughts on censorship and the likes of China. At the moment, China, I believe, still blocks TLS 1.3. So, if you like,
I wouldn't. I'm not sure that's true. Actually, I'm pretty sure that's not true. China doesn't block TLS 1.3. They might. First of all, it's not that easy to block TLS 1.3 because it kind of looks like TLS 1.2. And the second from my experience, we have some customers from China, and I haven't heard anything about such limitations.
Okay.
On the other hand, once ECH becomes a reality, they will block shit, shit
Well,
away,
yes. Yeah,
right?
yeah. There's an
Completely.
article. I'll put it on with the link to the recording afterwards. They certainly were blocking 1.3, but through
Sorry.
the Great Firewall. But clearly, that wouldn't necessarily hit 100% of all traffic in China. That there are backdoors which people will exploit from time to time. Just two other quick things. One was on which you sort of touched on. One of the disadvantages, in my view, of ECH is it does favour or reinforce the trend to centralisation because it is deliberately written for CDNs. Theoretically, you can run it across multiple cooperating server providers, but that's very complex. And I'm not aware of any use cases currently where there's any enthusiasm for that, as opposed to the likes of Cloudflare, etc., running it in-house. I mean, that's not a criticism of ECH per se, more than it's just another standard that in that trend. And then probably just the last comment, because people will be aware I'm not a huge enthusiast of ECH because of the potential negative impact on cybersecurity. Because certainly in an enterprise environment, it does lose a significant indicator of compromise, which is widely used for defense purposes. But in fairness, that's partly why people who've been tracking this will be aware. After some discussion, Google decided to make ECH an optional feature on Chrome, so that system admins could disable it in a corporate environment if they were using SNI as part of their defenses. So again, just by way of context for people, so not always a good thing in a corporate environment, but so you use with care. But what other comments or questions do people have? I can see that Nick has put in the chat that Deutsche Telekom doesn't use the sort of DNS type data, that doesn't monetize DNS data either. Yeah, which I suspected was the case. So thanks for clarifying that, Nick. But does anyone else have any comments or questions? Because if not, I'll ask you to maybe comment on performance implications. Andrey, just perhaps picking up on the conversation we were having earlier, but before the start of the call.
No problem.
So yeah. Oh, hang on. Question from Brian: which web servers support ECH? Don't you have any insight on that, Andrey?
Do you mean the web servers that? Do you mean the software or which CDNs support? Because if you talk about software, I'm pretty sure there's a Nginx build that supports ECH, and
Right.
even
Clarify if you're able to unmute or pop something else in the chat.
and if you talk about CDNs, so far I'm aware about Cloudflare only, but with limitations. So Cloudflare is not in a hurry to push it forward because, well, it's been in testing like for 2 years or so, and still they still only roll it out to the US and Canada only, and only to a very limited number of domains.
Looks like that was what Brian was seeking.
Today I did a quick check and I discovered just like 10,000 domains that have ECH config.
Just to add to that, I think in the ITF, in the TLS working group, I think it'd be fair to say that on ECH, Cloudflare, or people from Cloudflare have been some of the most active in the standards development, probably followed by people from Google. At least they were there when I've dipped in and out of the activity. Obviously, with a whole bunch of others as well, but numerically, I think I've mainly seen people from Cloudflare and Google in particular. So I guess it's not surprising if you've observed that it's been deployed there first, because I think Cloudflare did it deliberately. They enabled it deliberately to facilitate some of the interop testing, because obviously you need some servers out there if people want to test their clients.
Yeah, maybe.
Yeah.
But this is indeed a problem, ECH, I mean, in corporate environments, but not just in corporate. So, we've heard lots of criticism towards encrypted DNS about pretty much the same thing. Everyone was talking about corporate environments and all kinds of security and parental control features by the ISPs that, well, became probably broken. And with ECH, the same thing happens, which is not good. But well,
Yeah,
that's
I think on ECH, I think particularly in the corporate environment, a lot of firewall type software does use SNI, but obviously that's fine if you can disable the ECH as a feature in the client software. So if it can be managed by the sort of the system admins, then that's
kind of. But well, there's lots of IoT software. You can't do anything with them, and there's no. Well, it's not the world doesn't end with Chrome and browsers. And
no. That's
by the
true.
way, all this new tech, ECH, for instance, DNS encryption, it's well, you can't do anything and change anything with IoT devices that use it. So right now, I heard about Google Home devices using Google's DNS over HTTPS, for instance.
Yeah.
Might be wrong there, but well.
Yeah, that's a fair comment. Right. Anyone else got any comments? But pop them in the chat, or just raise your virtual hand on Zoom if that's easier. Just give me a chance to do so. Not seeing anything at the moment. Are you happy to share your slides, Andrey, after the call? Is that okay?
Yeah, of course.
And fantastic, because I suspect people will want to just sort of peruse those, and maybe that will prompt some questions, because there's quite a lot of content in there, which is fantastic. But as it's a relatively new topic, I give people a chance to sort of think about it, and maybe that will draw out some questions afterwards. Okay, well let's stop there then. So thank you. That's really helpful. It's sort of great, good to see that someone's sort of making the first moves to actually use the ECH in anger and find out what works well, what doesn't. No doubt, as the standard is finalised, others will follow in your footsteps, Andrey. But you definitely seem to have first mover advantage with the capability, much like you did with DNS over Quick 18 months, 2 years ago. So good to see AdGuard continuing to blaze a trail on these things.
Thanks.
Right, let me just change the subject slightly, not hugely, just to give people a quick update on some recent developments, but there will be a bit of a link back to this, as you'll see in a moment. If I just reshare my screen, not that one. Let me just try that again. Pressing the wrong buttons. Right. That's better. Okay, so just some quick news updates, which topically you'll see completely by coincidence. AdGuard, to its credit, I think AdGuard put out very interesting blog posts on a regular basis, and I noted that the most recent one, amongst other things, talked about support for DNS over HTTP as an experimental feature in the latest release of the software for iOS, which I know, Boris, you and I were chatting just before the call. You mentioned it is absolutely an experimental feature, and possibly performance-wise isn't as fast as perhaps, say, DOT at the moment, but that will potentially change over time. But again, just underlining the sort of first mover credentials of AdGuard in sort of pushing out support for new features. Also, ISC have confirmed that with 2.4.0 of the software being released, that now includes support for DOT, DOH options with DNR to discover resolvers. That's something that I think Vicky mentioned was being worked on a few weeks ago. So it looks like that's now shipping, which is good news. Some other interesting stuff. I won't go through all of these. You would have seen them in the weekly headlines. There's a sort of PhD thesis which people might find of interest, just looking at the resilience of the whole domain name system as a whole, and also DNS Filter put together a post on it's the first of, I think, two posts looking at the use of machine learning and its application in DNS security. And various other things, including at the bottom just an interesting discussion on the UK online safety bill, at least for those of us interesting for those of us that have an interest in policy matters. I see, Vicky, you've posted a question in the chat about anyone knowing which DHCP options, DHCP clients support the DNR options. So just to amplify that in case anyone on the call is able to answer the question. So if you do, perhaps post a response in the chat so Vicky can see that. There's a whole bunch of other things that caught my eye in the news this week. Again, I shan't go through all of those. I think there's an interesting one on APNIC about the power consumption of high-end routers. Not before time, in my view, because there's an awful lot of hardware out there that's running 24/7. So anything that can help reduce the power consumption is a good thing. And then, of course, there's a whole flurry of stuff on around social media, including but not limited to Meta's new Threads application as an alternative to Twitter, possibly, albeit with some criticism around its sort of privacy implications. So quite a few things happening this week, or the last week or so in the news, just to mention. In terms of some calls for papers and workshop proposals, I haven't picked up any new ones this week. So same two as last week. One from the DNS Research Federation, which includes potential for funding for academics with a deadline at the end of August, and also UK NOF has got a deadline at the end of September. But much more immediately than that, if you're planning to attend ITF 117 at the end of the month, the cutoff for internet draft submissions is 23:59 tonight, 23:59 UTC, before Data Tracker closes until the start of the meeting. And similarly, if you want to sign up to register to attend, the cutoff for standard rate registration is also 23:59 UTC today. So just bear that in mind. Yeah, and unsurprisingly, that's the next event that's coming up. So I won't say too much more on that. I haven't added any new ones yet. I will extend this, starting to look into the new year as we're now in July. So if there are any other events people want me to add, just drop me a line. I'll put them on, but equally I will start to extend stuff out, at least looking in the first quarter of next calendar. In case I forgot to mention it last week, I'm told that very probably IETF 119, which is due to be in Asia Pac, may well be in Brisbane, and that should be confirmed in the next few weeks, probably at IETF 117. There are just some final things being sort of sorted through with the potential hosts of the event. So possibly Brisbane in March next year, just for information. And then I've added a whole bunch of things in terms of future call topics. One of them, which I flagged as tentative, which is on 14th August, will move actually into September. That's the DNS errors and structured error data. So that will be September, actually, rather than mid-August. And then, yeah, I'll keep these up to date as we go on. So again, if anyone's got any topics you want either to be addressed by others or would like to cover yourself, then just drop me a line. I'll be happy to add those to the schedule as appropriate. I think that was, yes, that was it from me. So let me stop sharing and just open up and say, is there anything else that anybody else wants to raise under any other business this week? And if so, pop it in the chat, or indeed just raise your virtual hand on Zoom, and happy for you to come on. And don't forget Vicky's question she's asked in the chat about DHCP clients supporting DNR options, if you've got any views on that. But anything else anyone wants to raise? I'm not seeing any hands raised. Oh, Neil, is that you wanted to bring up?
Yeah, two things. I mean, I spoke to a few folks about DNR with client support. I don't know anyone who's actually implementing it yet. Obviously, as an author, I'm interested in people who are going to support it. The folks at Apple I know are interested in supporting it. I think what they're interested in is finding folks who are supporting it on the other end that they can interact with. So I think that's, there's kind of a bit of a chicken and egg situation there.
Yes.
I think there's other people are probably in the same situation. So yeah, so that might be kind of one of the reasons why there isn't support yet. But so having things like Kia supporting that is helpful. Yeah, so that's one thing. And I also have just something else as AOB, as it were, is I think we've kind of talked before about just in terms of encrypted DNS, there's not a huge number of people doing encrypted DNS, like in the wild, ISPs and telcos in general. I think we all know about Comcast. I just wondered if anyone has any anecdotal or other information about telcos out there who are publicly known to be doing encrypted DNS. Seems like a good place to.
Nick. So I see Nick has just put in the chat that Deutsche Telekom supports .ando, of course.
Yes, we have DOH and DOT enabled on all of our resolvers. So, and it's up to the customers to use it. If they want to use it, they are free to use it.
Yeah. And you mentioned Comcast. I think AT&T do as well, although Henny will correct me if that's completely wrong, I'm sure.
Correct. Correct. AT&T has a public-facing encrypted DNS platform. It's up to the customer to use it as well.
Great.
But has anyone implemented DDR because up to the customer means that no one uses DDR or DNR.
We have seen some traffic on it.
We
have seen some traffic.
It's not used on big scale.
Are you publishing DDR records?
I'm not sure. I can get you an answer to this question.
Because DDR seems to be rather widely supported by Windows 11 and Apple devices. So if you publish it, then, well, the number of clients will rise very quickly.
Yeah, I think the challenge, certainly in Europe, to an extent in the US, is the extensive use of CPE and DNS forwarders, which was I think something which was overlooked early on, but hence the development of DNR in particular to support that architecture, to hopefully solve that problem. Because I think the issue was when DOE was developed, the discussions, if we cast our minds back a couple of years or so, a lot of the people leading on the development were very US-centric in their knowledge base, and were unaware how common the use of DNS forwarders was. And it was only when Eric Orth, I think, looked at the data helpfully from Google and flagged that something like 85% of traffic seems to require forwarders, which is what prompted the sort of thought into how best to support encryption in that architecture.
Yeah, and note, even though obviously I love DNR, and hope everyone support DNR, you don't have to use DNR on a CPE to solve the forwarder issue. If you've got a CPE that supports DDR, just like I was talking about a few weeks back with DNS disk, you can do it with DDR on the CPE as well.
Yeah. But maybe we need more focus on some interop testing to see what can be done there, because this still feels like it's very early days with implementation of the discovery protocols, which is always a weakness in getting sort of user-led adoption.
Yeah.
Perhaps it's a topic we should come back to and look at in a bit more detail. So good question.
That'd be nice if we could have a little round table with clients and server vendors and people running networks to talk about these sorts of issues.
Yeah. Okay, I'll make a note of that. If anyone wants to be involved in that discussion, just drop me a line and we'll get something scheduled. I suspect probably September will make sense to do that, give people a chance to give it some thought. And also conscious that some of our friends in Europe, in particular, will be less available through part of August. And yeah, good stat from Kurt about the dependency at the client end on Google and Apple, amongst others, in terms of moving the market somewhat. Okay, any other?
Do you mean 82% of the clients over an encrypted DNS, or I didn't get 82% of which clients?
I'm guessing that, Kurt, you probably mean 82% of, all client types. Thanks.
Well, I mean, I'm guessing that's HTTP's web traffic, right? Because there's also the traffic that you just do generally, which, like, if you're on Windows, you might be using Chrome, but Windows is also doing a ton of DNS traffic, and so you're going to be relying on Windows to support DDR, which
it's browser specific. You're just looking at the link that Kurt has helpfully put up.
Exactly. So I think Windows also has an important role to play there.
Yeah,
certainly on the desktop side.
And as Andrey mentioned earlier, let's not forget IoT devices etc., etc. There's a whole bunch of other stuff, but not to say that browsers are not important, because they clearly are in this space. Yeah. Okay, any other things anyone wants to raise? Just keeping an eye on the time. We've got about 30 seconds probably left of our allotted hour. Not seeing anything. Okay, well, as we sort of time out then, thank you, Andrey, for the presentation, and I see you've dropped the slides through as well, so I'll share those post-call. So I really appreciate that. Hopefully that will get people looking afresh at Encrypted Client Hello, and also looking at your AdGuard's very regular blog posts, which also, in my view, seem to cover interesting stuff on a very regular basis. So definitely worth people looking at those as well. But other than that, thanks everyone for your time this week. Have a fantastic week, and we'll catch up again same time next Monday. So have a great week all. Bye.
Thanks, Andrew.